Hello and welcome to AI4. Our next session will be led by two speakers from Samasource. Sveta Kostinsky is the Director of Sales Engineering, and Marcelo Benedetti is a Senior Account Executive. Please join me in welcoming them to our virtual stage.
Thank you, everyone, for taking the time to join this session. My name is Marcelo Benedetti, a Senior Account Executive at Samasource, and today I'm joined by my colleague, Sveta Kostinsky, our Director of Sales Engineering. For those that don't know, Samasource is a leading training data provider with over a decade of experience supporting a diverse range of industries and machine learning use cases. Our talking point today is how AI is changing the shopping experience. First, we'll be discussing how AI is currently adopted by retail and e-commerce companies. Next, we'll take a glance at what the future holds for this space. Then we'll discuss the importance of data quality. And lastly, we'll be going through a live demo of our platform. For retail and e-commerce companies, adopting AI is no longer a nice to have. It's a necessary step towards improved customer experience, streamlined operations, and market competitiveness. According to a survey, 52 of respondents in the retail e-commerce space reported leveraging AI, compared to only 27% in all other industries. And with a recent study showing that over 50% of customers are likely to abandon a retailer after just one single bad experience, it is critical that retailers and e-commerce companies use AI to work for and not against them. So now we'll look at how these technologies are being adopted today and what that means for the end consumer experience. Most, if not all, current AI applications in retail fall into one of these four buckets. With personalized shopping, we see use cases such as targeted product recommendations based on buyer behavior analytics. Search relevance directly affects how quickly and easily shoppers are finding the products they need. Leveraging NLP to offer enhanced automated customer support is critical, especially in a post-COVID world with more consumers shopping online. And lastly, adopting smart automation into operational logistics, such as inventory management, order delivery, and pickup. So we're all shoppers and we've all visited hundreds of different stores, both online and in person. Of course, the truth about shopping is that whenever you visit a store, the majority of the items you're going to see aren't actually the products you want. No matter which store you're shopping in, you'll likely have to sift through a ton of different irrelevant items before you find what you really need and are looking for. Through personalization, brands now have the power to turn every shopping interaction into a meaningful, rewarding, and efficient experience. And that's exactly what shopping should be, right? Fast, simple, and personalized. By analyzing consumer data, such as web browsing habits, historical shopping data, and even social media activity, brands are able to tailor shopping experiences to customers' interests using AI and automation. So what does that really mean for the consumer? Well, consumers are then able to find relevant products that genuinely interest them without specific searches for these said products. This makes the shopping experience feel more custom tailored, making shoppers much more likely to buy. In e-commerce, relevance has become and remains the underlying criterion for measuring the effectiveness of search. When a customer searches your website for products, the idea is that the results shown to them should be as close to what they are looking for as possible. If shoppers are unable to find what they're looking for efficiently, they will often immediately go to a competitor's site. Within the category of search optimization, retailers are using numerous AI applications to improve results. Some of these are search result re-ranking, attribute re-ranking, visual search, voice search, and autocomplete. One example is how Walmart continuously ensures its retail inventory is comprehensively cataloged. If an item isn't properly cataloged, that may impact reporting of inventory levels and misrepresent availability of the product to the end consumer. In this scenario, AI technology is used to classify products so Walmart systems can accurately sense availability. With the help from Samasource's expert data annotators, Walmart was able to use machine learning to improve its retail item coverage from 91 to 98%. We have actually also partnered with eBay on a very similar use case, but instead using visual search. And we've partnered with them over the last several years on this. So what this means for the end consumer is that when they search for a particular item, they are significantly more likely to find exactly what they're looking for, adding additional efficiencies to the overall shopping experience. Today, most companies are choosing to leverage AI and automation to complete, augment, and personalize customer service interactions to deliver improved customer experience across various channels. This entails leveraging natural language processing that can interpret text and voice-based interactions with consumers. So what are the advantages of using these automated solutions such as chatbots? Well, they can substantially reduce operational costs for retailers, make customer service agents more productive, provide greater visibility into actual customer needs, expectations, and behaviors, and create an increased customer engagement and personalization, leading to a more satisfied and loyal client base overall. This is especially relevant in a post-COVID world with consumers shopping online more now than ever before. So how does this impact the shopping experience? It means consumers will have access to 24/7 customer service, instant responses to simple questions, improved overall communication, and faster issue resolution, which in turn enables consumers to spend more time shopping. AI implementation is making a huge difference for retail supply chain optimization, as there's a great need for fast delivery to shops and end customers, and an increasing focus on tight inventory control. Such application helps retailers understand exactly how their supply chain is operating, make improvements throughout, and eliminate waste and overhead. This is especially true when it comes to inventory management. While the conventional form of inventory management was restricted to current stock levels, AI-enabled inventory management is unlocking how companies can maintain stocks based on data related to sales trends over previous years, projected or anticipated changes in product demands, and potential supply-related issues that could impact these inventory levels. Also, the introduction of automated robotics and retail inventory management will greatly impact the future of operations. These robots help to cut down on the redundant process of sorting so that workers can take on more creative and collaborative roles. Also, studies have shown that humans are sometimes more prone to error when they find a job too tedious, which is an issue that these automations would help alleviate. One example is Walmart's introduction of the AlphaBot, an autonomous warehouse robot that helps to enable quicker, more efficient order picking. The system operates inside a 20,000 square foot warehouse style space, using autonomous carts to retrieve items ordered for online grocery. After it retrieves them, AlphaBot delivers the products to a workstation where a Walmart associate checks, bags, and delivers the final order. The end result for this example and others like it are that customers can expect a more efficient order delivery and pickup process, a reduction in order errors, and a better customer service, with associates being more focused on helping the end customer. So where do we go from here, and what does the future of this space look like? Well, US e-commerce sales as a percentage of total retail sales have experienced a massive hockey stick growth in 2020, largely due to the impacts of COVID-19. One recent study by Forrester shows that there has been the equivalent of 10 years growth in 3 months this year alone in terms of US e-commerce penetration. With more consumers transitioning to shopping online, retailers and brands will be focused on leveraging AI and automation to automate e-commerce operations as much as possible. In the near term, this will mean more emphasis on customer service, including more advanced and accurate chatbot capabilities, enhanced personalization and personalized shopping functionalities for online consumers, and logistics automation around inventory management and pickup delivery order operations. In the future, we can expect some exciting innovative breakthroughs to take hold in this space, such as autonomous checkout. Though the widespread adoption will take longer than many expected due to various logistical challenges, such as adapting the technology to various store layouts and retrofitting existing stores, we have seen some promising developments. One example being Amazon's autonomous checkout deployment, as we've seen with the Amazon Go stores, and also a very recent announcement as of last week, actually, that Circle K, a convenience store chain in Arizona, has partnered with Standard Cognition to implement an autonomous checkout pilot at one of their Phoenix locations with a plan to grow in the near future. So how can companies rapidly implement all of these exciting AI-driven applications in use cases that we've talked about today? Well, through high-quality ground truth training data. I'm sure we've all heard the term garbage in, garbage out, which has since become cliche in this industry, but it couldn't be more true when it comes to trying to efficiently build a new model or fine-tune an existing one. If your AI training data set is garbage, the resulting algorithm will also be subpar. A false positive in machine learning might produce a poor customer service experience for an e-commerce chatbot, erroneous product recommendations, inability to find a desired item, or a multitude of possible shipping errors. So how can you be sure that the data you're getting is actually useful? According to a McKinsey Global Institute research study, obtaining high quality data sets is one of the top limitations for AI adoption. However, it can be a challenge to obtain high quality data sets at an affordable cost and scale. Regardless of your use case, an effective training data strategy can help you establish a firm baseline for data quality. Start by clearly articulating your end training data goals. This will help determine what data needs to be collected, as well as the level of data quality required to meet that goal. Dataversity shares 9 dimensions of data quality to keep in mind in order to reduce the risk and cost associated with poor quality data. This includes data accuracy, completeness, consistency, integrity, reasonability, timeliness, uniqueness, validity, and accessibility. High quality data is imperative to the success of your algorithm, and having a dedicated team can provide the added benefit of industry and use case expertise. Over the last decade, Samasource has submitted over 500 million labeling tasks with tens of billions of labels to train our partners' machine learning models. With our vertically integrated workforce, robust annotation platform, and consultative approach to project management, we have the knowledge base and firsthand experience to help our partners efficiently train their algorithms while getting the most value out of their data sets. So now I'm going to pass the baton over to my colleague Sveta, who will do a deeper dive into the overall quality process, AutoQA, and a demo of our platform.
Thank you, Marcelo. I'd like to start with talking about the quality process that we have in Samasource, and how do we ensure that we achieve this high quality annotation through both process as well as technological advancements. We start every project by defining something that we call a quality rubric with our clients. And that quality rubric would capture the quality requirements for that specific project. And that would include accuracy levels for annotation, the different labels that we should capture, and other error types that we should be aware of. Then we're going to take that quality rubric and make sure that the agents during the training phase are going to be trained against those error types. Then they're going to be qualified for production prior to actually moving from the training stage into the production world. Our internal QA sampling portal will allow our QA managers to go inside the sampling portal and sample the work of our agents to determine whether it meets the quality requirements that were set in the quality rubric. Our clients can also access the same sampling portal to provide direct feedback to the agent and shorten the feedback loop, rejecting, approving the tasks, and providing detailed feedback on the task quality. We also have automated sampling, essentially 2 automated features capabilities, which are goal tasks and automated QA integrated into our technology. I'd like to spend a few slides talking about specifically AutoQA. So what is the AutoQA capability, and how do we use it in Samasource to ensure we achieve this high quality data annotation? When our clients, looking at the standard data annotation process where clients would create tasks over API, submitting them into the Sama Hub over API, where our agents or data trainers annotate the task, and the next step would, the task would reach the modern LQA, we would plant the AutoQA validation step in the middle. And that validation step allows us to validate the task results against a fixed set of rules that is configured to check for invalid combination of labels, errors within a shape, errors across shapes, or dependencies in the metadata. Things like ensuring that there's no logical errors are delivered, creating instance feedback loop to prevent logical fallacies, and essentially helping data trainers to adapt quickly to and being agile with the changing project instructions. We often see that our clients would like to change the instructions and make the change quick without losing the quality, without compromising on the quality of the project. So having AutoQA really helps greatly with providing this and closing this feedback loop quickly to the data trainers on whether they're able to achieve the tasks within the same level of quality on the new instructions. Some use cases where this will be super useful is being able to capture invalid answer combination of, for instance, if a few different labels were improperly grouped together, size requirement, making sure that the label is, that we're not labeling labels that are not supposed to be labeled and below or above a certain pixel threshold. So in a sense, in short, in summary, AutoQA, it will overall improve the time per task and will allow us to deliver tasks quickly in a higher quality. Let's take a look at a specific use case, which Marcelo touched upon, which is the automated checkout use case, and see how AutoQA can help us capture different errors when it comes to that specific use case. So the way it described for this specific task, this task should be annotated with 15 key points. It should, the grouped label should include a label of bounding box for the head, a label of bounding box for the torso, and a label of bounding box for the full body. And it will also should have the correct gender attributes for all the labels. AutoQA can capture errors such as the ones that we currently see in the label list on the right side. Looking at the label list, I can see that person 1 that is annotated right here has 2 labels marked as torso. So it's essentially missing the head bounding box, and it has an incorrect grouping. I've grouped labels that shouldn't be grouped together, and I have an inconsistent attribute selected within the group. One of the labels is marked as male, and the rest of the labels are marked as female. Here are a few additional errors that the AutoQA can help capture. I can see that there is a repeated group ID for person 1. It appears twice on this label list. And there is also the key points are grouped with wrong torso. So I have an incorrect group bounding box. So these are just a few of the error types that AutoQA can help us capture, making sure that we reach the high quality labels faster and with a higher efficiency. Now let's take a look at our proprietary platform, the Sama Hub, and the actual labeling process. But first I want to show you how would a labeled task look like. And this is our Sama Hub platform. It's a web-based platform, a proprietary platform. And we're currently looking at the portal, the sampling portal, which both our QA managers as well as our clients can access to give feedback on the annotation quality. Looking at this specific use case of the cashier list checkout and the gentleman picking up this cucumber, it's pretty important for this specific use case to be able to group all this object together and to track this object in temporal, for the temporal tracking across the different frames. So the Sama Hub it's a completely customizable space. The label list is completely customizable based on the specific project requirement. Allows you to create different types of labels, including multi-level menus, radio buttons, and a variety of different labels to meet your project requirements. Looking at the actual annotation process, I can use our bounding box annotation tool right here, the crosshair tool, and start the annotation. You see as I'm dragging the crosshair, inside I will have the numbers showing me how many pixels I have within that specific bounding box. This is really valuable for me to understand whether I need to annotate that specific object or not, and does it meet the minimum and maximum threshold requirements. And now that I've annotated this bounding box, I can go ahead and choose that this is person number 2 and advanced the flow a few frames until I see that my object is a little out of frame. So what I'm going to do here, I'm going to readjust the object in this specific keyframe to include the object inside my bounding box. So what we call these 2 frames are keyframes. And essentially we use linear interpolation between these 2 keyframes where the system will automatically fill in the details and annotate all the labels in between. This is a great time saving and efficiency for annotation. It means that you don't need to annotate every frame. You just need to annotate the frames where the object is making a shift from its course and you need to correct the bounding box. Additional platform capabilities that I wanted to show you is not only the ability to capture static values for each object, but also dynamic values, like the dynamic changes in object state. In this specific case, it can be object occlusion. For example, if I fast forward a few frames, I will see that this object is going to start being occluded around this frame. I will mark occlusion as 30%, and you can see that marked right here in the bottom with a little diamond. Fast forward, occlusion in 60%, and occlusion in 100%. This functionality is extremely valuable to allow me to capture dynamic changes in my object and to capture complex behaviors beyond just the object moving and changing the position across the frames. It allows me to capture different states of the objects. So far, we were able to review some of the capabilities of the platform to highlight how does these capabilities benefit specifically to this cashless checkout use case, and how this will allow me to make sure that my annotations meet the high quality bar as well as efficiency in terms of the annotation time spent. Thank you for your time today, and please let us know if you have any questions. We'll be around and happy to answer any questions that you have.
Thank you so much for that insightful presentation. The virtual crowd is going wild. All right, if you are looking for your next session, you can go ahead and check out the program page or take some time to do some virtual networking or connect with our sponsors in the exhibit section. Thanks again, and we look forward to seeing you around.